In the content, you should have went over the discriminant. And the discriminant is the part of the quadratic formula that's under the square root. So this isn't the full quadratic formula, it's just the piece that comes inside the square root after you do your negative b plus or minus the square root of b squared minus 4ac all over 2a. And we call it the discriminant because it allows us to discriminate or make a decision, because discrimination in the negative sense is making a decision based on what you see, not what actually is there. In this case, we are making a decision based on what we have here, but it doesn't have the negative connotation to it, because quadratics can have up to 2 zeros. The zeros are where it crosses the x-axis. So I could have 2 zeros. I could have 1 0, or I could have no zeros. And sometimes we just want to know how many there are. So you could do the whole formula, find them and say, hey, look, I found 2, therefore there are 2, or I found 1, so there's only 1. But it's quicker if we just look at the discriminant, and it's all about what the sign or the value of this is. 2 zeros is when the discriminant gives us a positive. 1 0 is when the discriminant equals 0, and no zeros is when the discriminant, which is the part under the square root, gives us a negative, because there is no real answer to the square root of a negative. So instead of doing the whole quadratic formula, I'm going to do b squared minus 4ac. So that's negative 7 squared minus 4 times 1 times 1. A is 1 because that's what's in front of the x squared. B is negative 7, and c is positive 1. Negative 7 squared is negative 7 times negative 7, which is 49, minus 4 times 1, which is 4, which gives me 45. I don't care about this. All I care is the fact that it's positive. Therefore, this quadratic would have 2 zeros. It would cross the x-axis in 2 places. For 2x squared minus 6x plus 5, I have my a, b, and c. Because they're not looking for the actual zeros themselves. If they wanted to know where they were, we'd have to use the entire equation. But because they just want to know how many would there be, I'm going to just go into that part. So I end up with negative 6 squared minus 4 times 2 times 5, which gives me positive 36 minus 40, negative 4. Don't care about the 4. It's the negative that tells me there would be no real answers, because when I did the formula, I would end up with a negative under the square root, and you can't square root a negative. X squared minus 6x plus 16, so b squared minus 4ac equals negative 8 squared minus 4 times positive 1 times 16, which gives me 64 minus 64, which gives me 0. So if I were doing the whole formula, I'd only get one answer, because the square root of 0 is 0. If I add 0 to a number or subtract 0, it doesn't matter. I get the same answer. So I can get an answer, but I will only get one answer, because I get the same whether I add or subtract 0. So now, one root of a quadratic is 3 plus the square root of 2. What is the other root? And find the equation if the parabola passes through the point 2 minus 4. Now, the thing about quadratic roots is when they're ugly, they always come in what we call these conjugate pairs. So if one answer is 3 plus the square root of 2, the other answer has to be 3 minus the square root of 2. The root is always at the end, and it's the opposite operation in between. It can't be root 7 or root anything else. It has to match this with opposite signs. So roots literally mean our answers for x's. So those are my two answers. They want us to work backwards. These have been solved to get these. So I'm going to kind of unsolve them. I'm going to bring everything back over with the x. So I get subtract 3, subtract root 2, and because I've emptied this side, that equals 0. Similarly over here, I'm going to unsolve, because I'm working backwards, or bring everything over. So those were my two brackets for this quadratic. So now I'm going to put them together. Don't worry about all the ugliness that's happening. Some cool stuff is going to come about when we multiply. So now I'm going to FOIL. X times x is x squared. X times negative 3 is negative 3x. X times root 2 is plus root 2 with an x. I'm going to take the negative 3 to get negative 3x. Positive 9 because I'm multiplying. Negative 3 root 2. Now I'm going to take the negative root 2. Negative root 2 times x is negative root 2x. Negative root 2 times 3. Negative 3 is positive 3 root 2. And negative root 2 times positive root 2 is negative root 4. When you're multiplying radicals or roots, you multiply the numbers inside. Some things here look like a quadratic. That looks like a normal kind of thing that I'm used to seeing. This other stuff looks weird, but we'll see what happens. So I have x squared minus 3x plus 9. Here I have a plus root 2x. Here I have a minus root 2x. They subtract out to 0. Here I have a negative 3 root 2, and there I have a positive 3 root 2. They subtract out to 0. So the only thing I'm left with is this negative root 4. Well, the root of 4 is 2, so I can actually calculate the square root to get 2. If I collect like terms, I end up with a quadratic equation. Negative 3x subtract 3x is negative 6x, and then 9 subtract 2 gives me 7. But the problem with a quadratic equation is there could have been a number in front that I took out first. So this could have all been doubled or tripled or times negative 2. So there's always that a value. Sometimes a is 1 and you don't really see it, but it's there. That's where this is going to come in, because I'm going to solve or sub 2 for x and negative 4 for y to figure out that a value. So that means negative 4 equals a times 2 squared minus 6 times 2 plus 7. So negative 4 equals a times 4 minus 12 plus 7. So negative 4 equals a times 1. So I don't need to divide by 1, but I really do bring it over and divide. So a equals negative 4. So now I'm going to bring that back up into here because this is almost done. This is a quadratic formula, and I just needed to know, was there a number in front? So negative 4, x squared minus 6x plus 7. And because we've really spent this whole question working backwards, I am going to put the negative 4 in. So there's my equation.